Okay.
Because I thought it had to like exactly.
No, but like,
Yeah. So if it's not there, I'm not talking about that.
Like,
Oh.
Oh, yeah.
I was in there.
I don't.
that's what they're doing, but it's an odd.
Can I join this dialogue?
I'm going to like. I think it does,
No, I'm not.
okay.
No, wait, so then there was.
Okay, folks, time is up. Let's
You just- I did.
okay, folks,
I think I've got it.
let's go over this together. I'm gonna call on someone to get us started. Just tell us whatever you know about this graph. So Nia, can you help us get started with this? What'd you do first?
It into the numerator would be x plus 2 times x minus 1.
Okay,
Denominator would be x minus 2 times x minus 3.
okay. And what does this tell you here?
Well, the coefficients of both the numerator and denominator are 1, so the horizontal asymptote is 1.
Okay, so we know that immediately, huh?
And then
What's the equation? The horizontal asymptote is y equals 1. Okay, so like here at 1, we'll have this. Okay,
asymptotes would be x equals 2 and x equals 3 because they're in the denominator.
are we good with this, everybody? Okay. And I'm gonna stop you right there and thank you for your input. Appreciate that. Before we continue with the graph, would you please discuss with your neighbor how you describe horizontal asymptotes using limit statements? Horizontal asymptote using limit statements.
As approaching.
Wait, there's gotta be two. Why?
As the limit.
As x approaches the
Wait, it's as. Five. Limit 5.
Okay,
Reaches.
so let's see what you got. Shiv, were you able to break this down in terms of limit statements at all?
Not really.
Well, let's start. We know there's a lim, right? Okay. Anything else? Maybe x going to somewhere?
Yeah.
Where?
Infinity or no, it's a vertical, no.
No, the horizontal asymptote. So would that be infinity?
Yeah.
Yeah.
X is going to infinity, so of f of x. In this case, it's equal to 1. And there's one more limit
Oh, it's just the.
of x. What's that?
X is.
Negative infinity, exactly. Thank you. So it was up there. I see. Just need to dust it off a little bit. Thank you. Was it? Yeah, Max, you have a question?
We just do like plus or minus.
You can do plus or minus infinity if you like, as long as it's the same thing. Okay. Simran, can you help us out with this graph? What should I do next?
Test the number. So I started on the right side.
So that's the next thing you did after the asymptotes?
Oh, the zeros.
Okay, so you found zeros?
Yeah.
Where are they?
One of them to be at -2.
Okay,
The other one to be at
nice. Okay. And before you start like testing numbers for positive and negative, was there anything else that we could do for that?
like label, I guess.
Like label like x, so we could do x equals 2 and x equals 3, and that's important. And y equals 1 over the horizontal. You found the x-intercept. Wondering if there's a y-intercept.
Oh, yeah. Sorry. Okay, I
Okay.
forgot to find. But you plug in 0.
Nice. And I think that's easiest if we just plug that into the original. So let's see that the y-intercept would be negative One third, is that right? Okay, negative 1/3. So, right. Negative one's down here, then have something like that. Okay, so you could do values and such to find where it's positive, where it's negative. So thank you for reminding us of that. My preference is to do as little work as possible going forward and still get it right, of course. And thank you for your input so far. So how can I just do it just as smallest amount of work and still get it right? Yeah, Connie, you have some ideas?
Looking at the three intercepts, see that it starts from below, going up.
Okay.
It's gonna cross the x-axis and it can't cross it again. So you know it starts like on the.
Oh, so you know it's not going to bounce off of it, right? Okay, and you say it can't come back down? Why not? Yeah, there's no more x-intercepts. Okay, so but is there a problem with this horizontal asymptote? It's okay to cross it? Is this true? Is it okay to cross horizontal asymptotes?
Yeah.
Yeah.
Yeah. An exception? Not sure. It can't cross vertical, but horizontal asymptotes can be crossed. They aren't always crossed. Okay, so Connor, if I'm picking up what you're putting down, it's just gonna go like this. Is that right? Did that seem, did I pick it up correctly?
So back down to approach that limit, like the statement.
So maybe like this.
No.
It could do this, but you know, why complicate things, right? I'm being a little bit ridiculous here. Probably just something like this is what you're looking at. Are we good with that? Do you want to continue? Before that, your question?
It would be wrong to put it like that.
What?
Like to go up? Yeah, why is this not gonna happen? Yeah, L. Okay. Not approaching horizontal asymptote. Any other input? Jonas?
If you try to solve for the horizontal asymptote, you should only really get one answer, and so it wouldn't make sense for it to be another whole. There is no answer.
Okay. Anything else? Yes.
It's not like. But I was gonna say, is it's not like kind of like a parabola? It's like not a quadratic.
Right. Yeah, we're not graphing parabolas here. You can't just do them, you know, reflexively. But I think I'm thinking about this. And as x goes to negative infinity, those y values are going to approach 1. So even if you went above it temporarily, it's going to come back down eventually as x is bigger and bigger and bigger. The y values will approach 1, and let's just keep it simple like this. Any other questions before we continue? Connie, do you want to continue?
Yeah.
Thank you.
So since both of the asymptotes are also multiplicity 1, you don't have to start this side on that x equals 2 asymptote. And then it's gonna just curve down to the negative side on the other one. So there's no x intercept. So it's just gonna be parabolic like that. Yeah.
Do we agree it's kind of forced down that way?
Yes.
And you said because there's no, we're forced to go back down because there's no there
X
x-intercept. Okay, and then
x equals.
so same kind of shape up here. And you sure that it isn't like down here?
Yeah.
Is it possible it's down there? There are 2 problems with that, aren't there? Yeah, multiplicity doesn't match, and we add another intercept. It's just we're a mess if we do something like that. So, yeah, Ron, thank you. So you didn't have to plug in any points, any values of x or anything like that? Would it have helped maybe? Probably not. Yeah, unless you want to know some specific y value, like I don't know, maybe if you want to know how far down this goes, you can plug in 2 point something. 2.5. Do you think that the top is right in between? It's not a parabola, so we don't know. We don't know. It's not in the scope of this class to figure out exactly how high that is or where that height is. But that general shape does go down like this way. Can we consider that a parabola though?
No.
Parabolas don't have asymptotes.
Oh,
They don't have asymptotes. They keep going out forever. The domain will be all real numbers for a parabola. But it is a curve. What are these three pieces of the graph called? Branches. Yay. Once again, thank you for your help with this. Any questions? Does this bring back some good memories?
Is this gonna help?
Oh, is it going to be on the test? Hmm.
but
The
maybe this,
midterm, yeah,
That's very.
I don't know.
whoa.
The test could have anything from the year. Each test could be cumulative. So maybe,
Disclose.
What's that?
Will you disclose before the test if it's cumulative?
Oh, I'm telling you right now.
Oh.
It could be cumulative. Yeah. But I generally don't give hints about what's on it, except whatever we've done in class, you're responsible for. Of course, the focus will be on the current unit. Okay, we are moving on today, and we're going to talk a little bit more deeply about something we already talked about this year, inverse functions. So my question I'd like for you to discuss with your neighbor is the following. If I give you function f and function g, and now listen up, and tell you that they are inverse functions, and then I ask you to prove that they're inverse functions, would you please discuss how you prove that f and g are inverse functions?
Oh, then you pause. I would just like.
Yeah.
Take a lead lag.
Person.
Yeah, they both.
Or if you draw it out. Give it
And
dark.
Yeah, I think he's trying to get at like getting.
Yeah.
Oh.
This should be equal to each other.
If you chart, then you can look and see.
So you think F and G.
Equal outputs.
Don't know that's equal to
Today.
Yeah.
Okay. So who could tell us, how do you prove that two functions are inverses of one another? Yes, Max?
Would plug one of them in as the x of the other, and then see if it equals x. And if it does for both of them, then you have inverses.
Does that sound familiar? So in other words, if f of g of x is equal to x and g of f of x is equal to x, then you have sufficiently proven that these two functions are inverses of one another. Now, do you know why this is true? And think about it. Do you know why this is true? Yes.
Because the inverse of like f of x, sorry, the inputs of f of x, like would get an output, and then when you have an inverse equation, the outputs and inputs switch. So like
Exactly.
your output is the new input.
Perfect. Yeah, that's exactly why. Does that make sense?
Yeah.
I'm going to show this visually, where this is just f of x. This is like a function machine. And so since it's a function, has inputs and outputs. So like if I put in a 3, then maybe the output is a 4. I don't know, if I put in a 5, then maybe the output is 11. I don't know what's in this function. It's a mystery box. All I know is that for each input,
There's an output.
there is
Oh no.
there's one out. There's one output. If I put in a 5 again, 11 is going to come out. Now, here's another function, and if f and g are indeed inverses, then when I put this in here, like Nia said, output's going to be 5. Does that make sense? Just the x's and y's are reversed. So using a different notation, but the same relationship. If I put an x in here, I hope that makes sense that what comes out is f of x, isn't it? And then what comes out if I put that into g? Well, g of f of x. And if it's truly inverses, then that should equal x. Because that's what went into the first box. And the same thing should, if they're truly inverses, I should be able to put x into here, which would come out with a g of x and plug that into here. So f of g of x, which would also result in x. So that's just kind of a visual representation of why we have this representation of, or this property of inverse functions. Yes? So as today is larger review, I'm going to just kind of be guiding you through problems. I'm not going to be giving a lot of explanations. You're going to be talking a lot with your neighbor through some of the problems. So today we're going to be doing 2.8. The homework tonight is going to be from the packet for 2.8. So let's get to it. And we have a quiz next time, is that right? That's so exciting. Will it include today's stuff? Yeah.
Yes.
No.
Let's
Silly. Silly. So 2.8. I'm not going to go over a lot of this. Oh, but I do want you to do, let's do a example for A from 2.8.
Right?
It's on this page with this stuff. I'm sorry. I'll try to make sure that the next packet actually has page numbers. It makes things so much easier. So example 4A. It's in 2.8. You're done or stuck, check with your neighbor. I will be calling on one lucky person to help us with this. Talk us through it. And check with your neighbor when you are done or stuck. Make sure they're okay.
How you doing, neighbors? Yes.
About 20 more seconds before calling the lucky individual. We're just working on A for now.
Oh, yeah.
It's okay.
So,
Okay. So, are we ready? Miley, can you help us out with this? Can you talk me through the algebra of the inverse, please? Okay.
So x equals y minus 2 over y plus 3. And then I multiplied y plus 3 on both sides and got xy plus.
Oh, that's great. XY plus. Okay.
And then I brought the y to the left side and then 3x over to the other. And then I factored out y,
Okay.
x minus 1 over x minus 2 and then divided x minus 1.
Over x minus 1. And instead of y, you wrote
F of the inverse.
f inverse of x. Do we agree? Is there another correct answer?
Yes.
There's one more correct answer.
3x plus 2.
3x plus 2 over 1 minus x. Right. That's equivalent. Either one is fine. I'm inclined to stay right here. It's a little bit more comfortable for me, but the other one has less negativity, so it doesn't matter. It's not a polynomial. You don't need to write it in standard notation or standard form. Are we good with this? Okay, before we move on, I'd like you to discuss with your neighbor, how could you have done this without algebra? Could you have done this without algebra?
I feel like it's a-
Maybe graph.
Graph it, and flip it over the line x minus 1. I mean, not that y equals x. Flip it over the line y equals x, sorry.
Yeah, okay. That's, yeah, so we're looking at, because you switch.
You know what I'm talking about without algebra?
Or you graph it.
We think that we should use pre-calc.
It's a good idea to use precalculus. For instance, here we know automatically that it has a vertical asymptote of -3, right? I should say x equals -3. So this, I'm not going to graph this, but because this function has a vertical asymptote of x equals -3, we know that its inverse is going to have horizontal asymptote of
-3.
y equals -3, which we see it has, doesn't it?
Yeah.
But couldn't we have just made a function that has like something like that? We just go right to that and ensure that it has
No.
a horizontal asymptote of -3. Hey, Haley?
Question,
Yeah.
if a function has an oblique asymptote, how does that correspond to the oblique asymptote for the inverse?
How does it correspond to it? Oh, interesting question. I imagine it is like some sort of reciprocal. I'm not sure off the bat. Interesting. I think actually it would be a horizontal asymptote of 0. As one is top heavy, then I think it'd be swapped. But how do we get the rest without algebra? How do you put the other pieces together? Discuss with your neighbor.
Well, the x minus 1 comes from.
I would just graph it.
The horizontal asymptote.
Yeah. The x y step, because x and y switch, so the y and.
So the
X was, then it's 2/3. The x intercept. And. Equation would be.
What?
What does that mean about it? Becomes a line.
When you
Oh,
just
that also works too.
Okay, so how would I do this without algebra? How would I continue? Yeah, Jonas?
You would, since we swapped the horizontal asymptote with the vertical asymptote, we did the same with the, making the vertical asymptote the horizontal asymptote, so that's how you get the x minus 1.
Wait, does that make sense, everybody?
Yeah.
Yeah, and then,
Nice.
and then finally you swap the x-intercept and the y-intercept, by making it, -2, which would make the y-intercept, 2, and make the x-intercept 2/3.
Like this?
Yeah.
Does that give us an x-intercept of -2/3 as well?
Yeah.
It does. Nice. Yeah, perfect. And it's a good match.
Wait. Wouldn't that give us an?
No, wait, it doesn't.
Let's see, equals 0. 3x equals 2, x equals -2/3. It's good. It's perfect. Do you want to try to do B without algebra? Let's see if you can do an algebra list. Just for fun. Just a fun exercise.
So like intercepting.
Only you have to do is.
Here is x.
Yeah, but I,
You got it? Check in with your neighbor when you are done or stuck. You give a hand, but not too much help. Don't give too much help unless they want, they're asking for it.
Okay, it's the first one, this. Very class of this.
That's what I got.
Oh. So the top is needed.
Yeah, it needs to be like.
Where'd you get the lines?
okay.
Should we start with the bottom? Bottom's gonna be X minus 2. Are we comfortable with that? And from that kind of flows something pretty quickly, doesn't it? We have X on the bottom, so the top is good. Oh, yeah, why is it X minus 2? Horizontal asymptote. Y equals 2. So vertical asymptote is X equals 2. So from here,
Here.
3X is on top? How do we know it's 3X on top? Right here, the vertical asymptote was X equals 3, so we know that ratio 3 to 1. And
+1.
Y plus 1.
It's the y intercept in the original was -1/3.
Y-intercept is -1/3, so we want 3X plus some, we want this to equal -1/3 when we solve it. So 3X plus something, I'll say maybe A equals 0. I think we can just figure that out. It's +1, you said? +1. It takes a little intuition.
Around there.
Yeah. And this -1/2 works out too? Is that something?
It's the x-intercept.
Is that, and it, so that works out to be the x-intercept for the original?
Still not.
Yeah. It's perfect. Kind of fun? A little bit? I think it's a neat exercise. Which one should you do on a test or quiz?
I should do whichever one you feel more comfortable.
At this point, either one is fine, but you should be able to do algebra. You should be able to do algebraically. The other one's kind of a shortcut, kind of a fun little shortcut once you understand the relationships, but you should definitely be able to do it algebraically. It works for linear over linear in very select case.
So the okay, wait.
So this method only works like the degrees are the same.
If they're both linear, they're both first degree. You can look over this on your own if you like, but I want to go directly to example 7. Check to see what your neighbor did. Make sure it's okay. Uh-oh.
I see something that could happen.
Make sure to talk to Emma about this, but she's your first line of defense here.
Do the other one, and then you'll see that one.
Oh, wait, no.
Yes, it is. Yes, it's X minus
But
ten.
it's like in 10.
Oh my
Square the square root.
You will be- Don't you want to clarify? Yeah, but fine.
It's all-
Yeah.
No, less than 10 is
This one is regular.
Yeah, I showed it.
Oh, I think I see what you mean.
No, it's undefined. It's less than-
Are you ready?
Square root, square, but X would be plus or minus.
Yeah, that's why, what actually.
Yeah, I did that.
Okay, folks, I want to hear what you did. Connor, can you help us out? What'd you do here? Connor, what'd you do?
I inversed it.
You inverse them. What do you mean?
Well, first you swap A of X, H of X with Y.
Okay, so make this like X equals Y, like this?
Wait, sure.
Is that what you're saying? I'm not sure.
I think you went a step ahead of what I did. No.
Okay.
no,
Oh, I see, you made this, I see.
Yeah, and then.
So we
I
could
put the
do
X and
that.
Y.
Would this be proving that they're inversing? It does. It's not a terrible idea. I'm seeing some hands up. Should you have,
Like just plug them into each other. Get X.
is that how this works?
Yeah.
You sure? So I have to find H of K of X, like I have to do that.
Yeah.
Let's see, H of K of X, so that is like this, and I just plug this into here. So I have square root of X minus 10. Do I really need to do all this work to show that these two are?
Yes. Well, I feel like
It's pretty dumb.
nowadays,
Or-
in the world.
I showed you the machines and everything, the function machines. Yeah, this is exactly what I need to see. This is the only way to show that
This is how you do it.
they're inverses.
Yeah, wait, I have like a little problem on the other side.
You have to show all that work.
So I'm sorry, Emma, did you have something? Connor, yes?
Don't you have to do it for the other one?
Yeah, Max just gonna do a half job here, right?
Square root.
It does? So should I just put an X?
Good.
Thank you.
Plus sign.
I'll just, so this one is K of H of X, so I'll go ahead and plug that in right here. So this is going into my square root, so X squared plus 10 minus 10, square root of X squared.
Wait, Mr. Lieberman, I was like right here at this moment, I was like, what if X is plus or minus?
Ah.
So what if X is negative? Then that doesn't work.
Now it's actually.
What kind of number comes out of a radical? Positive number.
Oh, wait.
And here it tells us that X is positive.
Oh. I was overthinking.
So yeah,
It's important to.
I do need to see both of these. If you're showing me that two functions are inverses, I need to see both, please. Yes.
Like, so I did like, if X equals 12, and then I plug 12 into H of X, and then I put 8, like K of H of X, and then I did it the other way. Like, could I choose a number? Or does it have to be X?
You could choose a number, but that only shows me an inverse relationship at a single point.
Oh, okay.
So I need to see all of them, which is why it's got to be the entire function put in together. But it's a good start. Any other questions? And this whole thing here is pretty lazy. Do they have to have the same domain?
No.
No.
They
don't
don't
have-
have the same domain and range.
Well, whatever the domain of this one is, and the range of this one is, they have to
Yeah.
be flipped.
They got-
Ultimately, I think that the author was just being a little bit lazy, saying if we just make it X is greater than or equal to 10, then there are no problems with either one. So,
Oh, so we don't have any.
yeah, so, right, so this is not an issue. But ultimately, that kind of thing it's more of a formality in general. Okay. Moving on. Oh, this looks like fun.
Wait.
Yeah, you should. Try 'em. Example one, it's the next page, right? Mhm. It is. Do you want to see your code?
Am I?
I think this is the next page.
I'll show you more context. Inverse functions part 2.
Oh, I see it. Thank you.
No problem.
Make sure your neighbors get the same thing you are.
But you don't have a certain person. So
You're really tickling my brain.
so this is, so you should. Negative.
And negative 3.
It's not, I don't. Oh.
Wait, but how do you? F of negative 2. And then the percent that.
I remember it.
And like 35
So,
because. Oh, G. What did you say? What do you think? I lost my glass. What do you? Simply because I got.
So whatever it is.
F of. I'm gonna.
Are we about ready?
That's pretty hard.
Okay, folks, can you show me what you got for A? Show me what you got. Nice, you remember the negatives, yes. Okay, -1. B, can you show me what you got there? Okay, so I'm seeing 4s. Could someone explain how they got that 4? Who'd like to tell? Someone who hasn't spoken today in class yet. To the class. Yeah, August.
So. So I saw that because the instructions say that it's the inverse f of x.
Okay.
So that meant that I'm looking for if -3 was the output, then what would the input be? Right. So that, and then I found that for f of x, when the output is -3, then input is 4. So that means that this is 4.
Does that make sense? What he was saying here? Exactly. We're looking at an output. Okay. Good. Thank you. Okay, so C, can you show me what you got? I'm seeing -3 all around. Okay. D, is that even possible? Okay. I'm seeing that you got an O. That's interesting. Or maybe 0, maybe something. E. That one didn't even take any work because they're inverses, right?
Cancel out.
Oh, that's true.
And F. I'm seeing a 4. Yes.
That question is the same as that.
Yeah.
Well, that seems like a cheat. We need to do some more. Let's try example 2. Go for it. So it's again to try to control that.
Oh,
Yeah.
There's 2 parts.
Just another few seconds.
Why wouldn't the maximum be inverse?
Okay, ready or not? I want to hear it. A, please show me the minimum, what is the minimum value of k of x? Please show me. Of k of x, so the first part is k of x, the minimum value is -3, the first part. And for a k inverse of x, I'm seeing some different things.
K of -1.
Not k of -1, it's k inverse of x. I think I saw more -4s than anything. Would like to explain how they got that, or if they don't think it's that, what you think it is and why? Yes, Nia?
It's an output switch. I just looked at the, like, the least, like the smallest x value of k of x, and it's -1. Since the inputs and outputs, like, it's like.
Okay. So you looked at the smallest input of the actual function. Does that make sense? Any other way to think about it? Well, yeah, let's talk about it in terms of domain and range for k. Is that pretty easy to find domain and range of k? Wall to wall. So -4 to 11, and that's given to us. The range is
-3 to 6.
-3 to 6. So for k inverse, the domain is -3 to 6, and the range is -4 to 11. Now, how does this help get a minimum value of k inverse? Yeah, Oliver?
Is the minimum value is the lowest number in the domain?
Lowest number in the,
Oh, sorry, in the range, sorry.
is this true? The minimum value is the lowest number in the range? Yeah, we're looking at a y value, so it goes all the way down to -4. So that's kind of laying it out, or yeah, really like what you said, just looking at the inputs of the actual function, so we can see the minimum value of the inverse. Simran, what do you think? Do you buy it? Okay. K inverse of 6. Show me what you got, if you got it.
Yes.
Sure you can. You have to take off a shoe. This will do it. And K inverse of 4. 6. Okay. Good.
We learned the
Oh,
symbol.
wait.
You did. The hand.
Oh, it's like this.
ASL. One last one. Example 4. The 6, 7, 8, 9. Example 4. You're welcome.
Yeah, it's got more than thing.
Wait, I looked at all the next time.
Oh,
I'll say 3. There's an interesting.
There actually is.
Oh, there
You
is.
sure? No. Here? Oh. Learn something new every day. Oh, it just went up to 5.
That's not even.
How do I forget?
That's my what?
I like D.
Advanced. Yeah.
I like D, Mr.
Like D.
-1,
How's it going?
-1.
Too much negativity. Do you check your neighbor's answer for A, make sure they're on the right track?
I didn't have to do it.
Nathan, buddy, and the audio is signed.
Yeah, yes. Each of six.
Okay.
And I go to 10. Here's.
G.
Yes.
I'm not too sure, but.
Are we ready?
The-
Can you show me A?
So you go to 10, -1.
A, -1, show me B.
So,
So B is 4. Is C? C is -1 and D. I'm seeing 6s. Okay. I'm not checking. Anyone want to disagree with one of these and explain how they got what they got? Connor?
For number. So we looked at -1 on the y-axis, and then it correlates with 10 on the x-axis. So then we plug 10 into each of -1.
So, I'm sorry, so you're saying that this is 10, is this true?
He didn't ask to explain, he just asked.
Wait, he's on to something.
Is, okay, fine. I'm just making sure. So,
And then
okay,
equals-
and that's 6? That's equal to 6? Okay, are we good with this?
Yeah. Wait,
Cool.
wait, we don't have the. Wait, I think we're fine.
H and 10 equals 6? Yeah, because this is just asking H of what equals 10. The answer is 6, so yes. There we go.
It's like a logarithm.
Thank you. It's what? It's like a logarithm. Yeah, nice. Your assignment can be started, will be started right now. It's both pages of 2.8. There are two different sheets in your assignment sheet for 2.8. Yeah, so enjoy. You're gonna love it. Right now, it's 111. It's 111. It does say 2.8. It should all be about inverses. So, yeah. So, 4 sides, two pages, 4 sides.
Day 6 before.
Sure,
I should have raised my hand, but can I use the restroom?
sure. Yeah, that's, you don't have to raise it. We can just go. Thank you.
It'll be third. Yeah.
Worksheet A, worksheet B.
Um,
Both worksheet A and B, right, for,
Yep.